Okay, let's be honest. We're all swimming in hype about AI and drug discovery. But today, we're going to cut right through all that noise. We're moving past the headlines to see what enterprise-scale implementation really looks like on the ground, based on what the latest industry analyses are telling us.
So here's our game plan. We'll start by untangling the completely contradictory stories about AI's performance. Then we'll nail down the metrics that actually matter in our world. We'll look at two very different strategic playbooks from a couple of industry giants, face the tough, real-world barriers to getting the stuff done, and finally, we'll peek into the future to see how this is all about to rewire R&D as we know.
All right, let's dive right into the heart of the confusion. Because there's this huge paradox playing out in the AI world. On one side, you hear these stories of massive, widespread failure. But then, you look at our corner of the universe, Biopharma, and the story is one of absolutely unprecedented success.
And this brings us to the big question for this whole explainer. How can these two things possibly be true at the same time? How can a technology be crashing and burning in the broader business world, but simultaneously be crushing it right here in drug discovery? It doesn't seem to make sense.
Well, the data behind this paradox is just stark. On the left, you've got this viral MIT report that says 95% of Gen AI pilots are failures. But look closely at how they're measuring that. A super short-term, 6-month return on investment. Now compare that to the data on the right from a really important BCG study. In our world, AI-discovered drugs are hitting 80 to 90% success in phase 1 trials. That just blows the historical average completely out of the water. The stories are different because the yardsticks are from different planets. And that's really the key. Judging AI's value in drug discovery on a 6-month ROI is frankly absurd. It's like trying to time a marathon with an egg timer. It's the wrong tool. You know, our R&D cycles take a decade, sometimes more, and cost billions. The value isn't in some quick cashback scheme. It's in the long-term game of de-risking the whole process and bumping up the odds of success. Which brings us right to our next section. So, if the 6-month ROI is useless, what are the right metrics for us? In biopharma, value really comes down to 3 things: cutting down time and cost, creating something genuinely new, and, the big one, dramatically increasing the probability of success. And this chart really says it all on that last point. I mean, just look at phase 1 success rates. Historically, it's basically a coin toss, about 55%. But with AI-discovered drugs, that number skyrockets to 85%. This tells us that AI is getting really good at designing better molecules right from the get-go, weeding out the ones that would have failed later for basic safety issues. That is a massive de-risking at the most fragile early stage. But of course, you'd gotta have healthy skepticism, right? A major criticism you hear is that some of these AI biotechs aren't really inventing new medicines, they're just, tweaking compounds we already know about. So is this real innovation, or are we just doing Me Too drug discovery but faster? To answer that, the field is starting to use much more rigorous quantitative measures. And a perfect example is the Tanimoto score. It's a way to measure structural similarity between molecules. If you get a score below 0.5, you're looking at a genuinely novel chemical entity. Using tools like this helps us get past the marketing fluff and actually measure true, data-driven novelty. But here it is. This is the ultimate metric. When you add up all these improvements, especially that huge jump in phase 1, the projection is that AI can nearly double the end-to-end probability of success for a drug. Think about that. Going from a 5–10% chance to a 9–18% chance, that is a seismic shift in R&D productivity. It could completely rewrite the economics of our entire industry. So with that kind of potential on the table, how are the major players actually organizing themselves to capture all that value? What we're seeing are 2 very different strategies, 2 distinct playbooks taking shape, and they're best seen by looking at what Flagship Pioneering and Eli Lilly are doing. So this table breaks it down nicely. Flagship strategy is all about venture creation. They build and they control a whole ecosystem of AI-native companies from the ground up. They're betting on the massive equity value of their proprietary platforms. Eli Lilly, on the other hand, with their Toon Lab, is all about ecosystem elevation. It's a collaborative, open model where they use their incredible proprietary dataset to empower external partners, creating value through network effects. 2 totally different philosophies. And the key piece of tech that makes Lilly's collaborative model even possible is something called federated learning. It's a really clever privacy-first technique. It lets partners train and improve Lilly's models with their own valuable data. But, and this is the crucial part, that raw data never, ever leaves their own secure servers.
It's an elegant solution to the IP protection headache that's always held back these kinds of deep data collaborations.
But, having a great strategy is one thing. Actually executing it is a whole other beast. Moving from a cool little pilot project to an enterprise-wide capability means you have to run what I call the implementation gauntlet. So let's look at the 3 big barriers that keep so many organizations stuck in pilot purgatory forever. And these 3 barriers, they feed on each other. It becomes this vicious self-reinforcing cycle. It all starts with the data, right? It's a mess, fragmented, low quality, stuck in old silos. That garbage data means the AI projects can't deliver real value, which then makes it impossible to hire or keep top talent. And we need a very specific kind of talent, people who are bilingual, fluent in both lab science and data science. Without them, there's no one to fight for the projects, so they get pushed to the side, kept at arm's length by organizational inertia, and the whole cycle just starts over again.
So how do you break that cycle? Well, it takes a really deliberate 3-level approach. First, on the inside, companies have to build their own scalable AI platforms to stop reinventing the wheel for every project. Second, they need to look outside and forge deep partnerships to get the data and skills they're missing. And third, at the whole industry level, we all need to engage in pre-competitive collaborations, like the ones the Pistoia Alliance runs, to set the standards and validation frameworks that will lift all boats.
So, where is this all going? Let's wrap up by looking at what's next. Because what's happening right now, it's just the beginning. We are on the cusp of a fundamental rewiring of how R&D actually gets done.
And the next giant leap is something called Agentic AI. This is where AI stops being just a tool for prediction and becomes a system that can reason, plan, and then autonomously execute complex workflows. I mean, imagine an AI agent that can analyze genomic data, propose a brand new drug target, design the experiments to validate it, and then order the reagents, all with very little human supervision. And this isn't science fiction. Groups are already building the standards to make this a reality.
And that, right there, leads to this profound shift. The very definition of being a scientist is about to transform. We're going to move away from being the ones at the bench generating the data and become the strategists who design, guide, and oversee these incredibly powerful AI-driven discovery engines.
So, I'll just leave you with this final, critical question to think about. As we move from all this hype to real implementation, what is your role going to be in this new, rewired R&D landscape? Are you going to be the one generating the data that feeds the algorithms? Or will you be the strategist who guides the autonomous AI as it drives discovery forward?